In the late 9th century, the Carolingian Empire collapsed. Its unified law dissolved, leaving regional lords to seize control of their own borders and power. This vacuum created the feudal system. In a landscape without central protection, survival relied on a local exchange, land in return for military service and absolute loyalty. Fortifications evolved to match the rising stakes. What began as simple wooden towers on dirt mounds grew over 4 centuries into massive concentric stone fortresses. To understand the engineering that protected these lands, we are going to simulate a siege, walking through the specific layers an attacking force had to survive to reach the heart of the castle. These strongholds functioned as defensive machines. Every architectural choice, from the height of the stone to the depth of the ditches, served the survival of the garrison. The moat served as the initial deterrent. By surrounding the walls with a deep, water-filled ditch, defenders stopped heavy siege towers in their tracks and prevented attackers from mining underneath the stone foundations. Survivors were funneled toward the barbican. This fortified forward checkpoint forced the enemy to weather defensive fire before they could even approach the main entrance. At the gate, soldiers turned a windlass, using pulleys to lift the heavy drawbridge flush against the exterior. For larger bridges, a bascule system was used. As the outer end raised, inner counterweight swung down into a pit to offset the load. This counterweight pit acted as a secondary trap. Even if an attacker managed to bypass the raised bridge, they were still faced with a dangerous physical gap that blocked their path into the gatehouse. These exterior layers were designed to exhaust the enemy. They drained an army's momentum and numbers before they ever touched the main curtain walls. At the base of the wall, attackers hit the talus, a thick, outward-sloping section of stone. This angle was calculated to snap scaling ladders under their own weight and deflect the energy of battering rams. High above, defenders utilized maculations. These stone floor openings, supported by jutting corbels, allowed guards to drop heavy rocks or projectiles onto any troops attempting to breach the gate below. The curtain walls were often 10 meters high and several meters thick. They used a layered construction, with 2 outer shells of finished stone encasing a core of rubble and mortar. While early square towers were vulnerable to their corners being undermined, the shift to round and D-shaped towers solved the problem. Circular surfaces proved much harder to tunnel under and naturally deflected the force of incoming projectiles. Because these towers projected out from the wall, archers gained clear lines of sight along the entire perimeter, eliminating blind spots for anyone trying to scale the stone. This configuration turned the outer wall into an active kill zone. The architecture weaponized geometry to ensure that any breach was immediately caught in a crossfire. If an army broke through the outer gates, they entered the inner gatehouse. This was a narrow, stone-walled tunnel designed to funnel survivors into a tightly confined space. Once the tunnel was filled, defenders dropped the portcullis, a massive wooden iron grid that slid down vertical grooves to trap the attackers inside. Trapped in the dark, the invaders were targeted through murder holes. These ceiling tents allowed guards on the floor above to rain down rocks, arrows, and boiling liquids onto the men trapped in the passage. The inner gatehouse functioned as a literal execution chamber. By creating an inescapable bottleneck, the castle could systematically eliminate a superior force even after its primary gates had been breached. Beyond the gatehouse lay the inner bailey. This courtyard supported the daily needs of the garrison, housing blacksmith workshops, stables, and a chapel for the lord's household. The most vital feature for surviving a long siege was the well. Having a protected source of fresh water inside the walls meant the castle could hold out for months without being forced to surrender to thirst. At the center of it all stood the keep. This multi-story tower was the lord's primary residence and the castle's final, most heavily reinforced refuge. The first floor housed the Great Hall. It was the social and administrative center, where the lord conducted business and hosted communal feasts. Even here, the design was tactical. Spiral staircases were built ascending clockwise, a choice that physically cramped an attacker's right-handed sword swing while leaving a descending defender's arm free to strike. This layout sustained the garrison through years of peace and weeks of war, functioning as a high-readiness barracks that housed the specialized labor of a small town. By the 15th century, the mathematical certainty of castle defense met a new variable: gunpowder. Early cannons were erratic, but as metallurgy improved, their power began to outpace the strength of solid stone. Heavy iron shot could pulverize a curtain wall in days rather than months. As vertical stone became a liability, engineers transitioned to low earthen ramparts that could absorb the kinetic energy of a cannonball. No longer needing thick walls for protection, the nobility moved into unfortified chateaux. They traded the military utility of the fortress for aesthetic prestige and the comfort of grand open estates. While their strategic value evaporated, the castles themselves remained. They endure as physical records of the feudal hierarchy. Structures built when a lord's influence reached only as far as his archers could see from the battlements.